Howdy, Chemsters. This is Bowles. Going to go over more electrons. I'm going to cover configurations, noble gas notation, and valence electrons in this video. So first off, don't forget your blocks. You got the S, the P, the D. You won't need to worry about the F. And remember that the D is filling the third, the fourth D, the fifth D, and the 6D right here as we switch into D block. So I'm going to go ahead and do the electron configuration for arsenic, AS. And if you notice here, arsenic has 33 electrons. All right, so we're going to need to start loading them in one by one. As you know, we always start on the upper left. So it's going to be 1s2 first. Then we're going to go across like we're reading a book. Nothing else on the first row. 2s2. 1s2, 2s2. Remember, the little 1 means first energy level, S sublevel, 2 electrons. Second energy level, S sublevel, 2 electrons. 1s2, 2s2. 2p holds 6. So we're going to put 2p6. So remember, if we're going to pass it, because we have to keep going all the way to arsenic, then we're just going to keep on writing them. 3s2. 3p6, 4s2, and now we're into 3d. That little 3 reminds us. That's 3d. It holds a maximum of 10. 3d10, and then 4p, back to 4 here. 1, 2, 3. 4p3. So that's the electron configuration for arsenic. Now, I want to show you the shortcut. The shortcut is called noble gas notation. You're going to love this. You're going to love this because it's going to save you a lot of time. Noble gas notation. So for noble gas notation, what you do is you look at arsenic and you go to the noble gas right before it, which would be argon. Not the one in front of it, because krypton has more electrons. We have to go to the one before it. So we go to argon and we put a bracket. So for arsenic, it's going to be argon with a bracket around it. That means take the configuration for argon, which goes all the way up to 3p6. So this part, all of it, includes argon. And now you can just skip it because you put a bracket. That means argon, take argon's configuration and add this to it. Okay, add what? What's left? 4s2, 3d10, 4p3. That's how you do it. 4s2, 3d10, 4p3. So you notice when you look at argon's configuration, it's whatever comes after that that you're adding for arsenic. So arsenic's noble gas notation is Ar, 4s2, 3d10, 4p3. The last thing I want to show you on this video is valence electrons. So let's say we went back to arsenic and we wanted to see arsenic's valence electrons. So this is how arsenic's electrons look when they're positioned in the energy levels. Remember, these are the energy levels. This one is n equals 1, energy level number 1. The second one is what we call n equals 2, n equals 3, n equals 4, to a maximum of 7. Arsenic has 1, 2, 3, 4 energy levels represented because it's on the 4th row or period of the periodic table. All right? So arsenic's electrons in the 1s go right here. And then the second, we have the 2s and the 2p. So that's 2 and then 8 total electrons in the second ring. The third ring for argon has the 3s, the 3p, and the 3d. Those are actually in the third energy level. They just happen to get filled after 4s. Now, the fourth ring has s and 3 in the p. 1, 2, 3. So argon's valence electrons are the very last ring. So for the valence, we can just get rid of or not even think about all the electrons on the inner rings. Those electrons are called the kernel of the atom. The kernel of the atom. The kernel of the atom has lots of electrons, but we only want to know about the valence electrons. The valence electrons are the ones on the outside. So for arsenic, it would be 1, 2, 3, 4, 5. There are 5 valence electrons for arsenic. Now, if you look at all the other elements and you want a quick way to find out how many valence electrons they have, you just look at what column they're in. Those in the first family, 1 valence electron. That's how much is in their outside ring. Remember, S1, S2, over here, 2 in the S, 1 in the P. That means 3 valence electrons. These guys, next door, 2 in the S, 2 in the P. That's 4 valence electrons. 5, 6, 7, and 8. That's what makes the noble gases special. They have what we call an octet, a total of 8 valence electrons. And that's how you do it, folks. The ones in the middle here, students will ask, how many do they have? Those guys have their S's full. So we'll just say that they have 2 valence electrons for right now. It gets a little more complicated, but that's the basics. All right, go get them, my friends.